Hello, this is your friend Ken. On my previous video, I have done one demonstration of flipping the matrix. Yeah, but it was without explanation. Many people want me to make a video with the explanation about the logic and the underlying structure of the code. So in this video, I'm going to discuss about my idea and my thinking about the solution. Okay, so because we should try the upper left quadrant. So because 4, 2, 1, 3 is actually segregate, and then we need to try the upper left. We need to try this element out of these 4 integers. So and then the function description completes the flipping matrix function in the editor below. So yeah, basically this is the function. We need to type the code here. And the flipping matrix has the following parameters: int matrix 2n and then another 2n, a two-dimensional array of integers. The maximum sum possible. Input format. The first line contains an integer q, the number of queries. The next q sets of lines are in the following format. The first line of each query contains an integer n. Each of the next 2n lines contains 2n space-separated integer matrix I, j in row I of the matrix. So I think this is basically about the input, like what we have to input. For example, like here it tells the first line contains an integer q, the number of queries. So here it is 1. That means there are 1 query. Then the next q set of lines are the following formats. Okay, then the next so the first line of each query contains an integer n. So like here, and again it types 2, and then n is equals to 2. Each of next 2n lines contains 2n space-separated integers. Okay, so 2n lines, 1, 1, 2. Yeah, because n is equals to 2. 2n means 4. So like and then we type the matrix of I and then of j. So that is basically like 4 times 4 means 16 elements. So we can just input this this type of the values of to fill the matrix of 4 times 4, and then output is 414. So why it is 414? Because here is the explanation. Start out with the following 2 times 2 matrix. So yeah, probably I want to figure out the meaning of query. Okay, yeah. Okay, query means to check. Okay, so it can only check for 1 time, and integer n. All right. So yeah, and also the you can see here, like the each of the elements, it doesn't have to be in any ascending or descending order. It can be any random order, and it probably can also be repeat as well. There is no restrictions. So this is basically the 2n times 2n matrix. So yeah, 2n times 2n. I assume that suppose here n is 5, then it's going to be 10 times 10 matrix. It's going to be 100. Okay. So and perform the following operations to maximize the sum of n times. Oh yeah, I got it. Because Why? Because here it tells about the up left corridors. So like they use that the n times n among 2n times 2n. They use this tricky way to let it automatically query the up left corridor, right? No, not corridor, up left quadrant. So this is basically the case, right? So and then reverse column two times reverse column. Okay, so where's 83? Yeah, okay. So reverse column 2, because it starts from 0, right? So column 2 basically means the third column. So 83, 56, 101, 114, 114. So we reverse it to make this number up, right? And then resulting in the matrix is going to be like this way, and like the rest of things to remember. Maybe probably I can just use this to identify it. Yeah, so like it just reversed at this column, right? And then reverse row 0, 112, 42, 114, right? Why it is because I think basically is because on this matrix, like you can because we only have the limited chance to query it. So like this one, 114 and 119, this one is at the end. If we reverse, we can quickly to we can quickly to move it to the up left quadrant. Yeah, we can instantly. But imagine this one, like for example, why not 125? This is even larger. Because if we reverse it, because it's already in the quadrant, it's already in our intended quadrant, and also it's not in the last position. So that's why we didn't do that. We didn't process that. Okay, then and then the third is to reverse row 0. Okay, row 0, like as we already taught, it means the first row. We reverse it and then to make 119 at in the beginning. Okay, yeah, why yeah, and also most importantly because it doesn't reverse from the original, it reverse from step 2, right? So then we just reverse it and then we made 119 here and one and here. I think we just make it opposite to count from right to the left, right? So that's the case. So then the sum of the volume in the n into n submatrix in the up left quadrant is, yeah, it's basically this one. I think now is 119. Yeah, 119 plus this plus 114 plus 56 plus 125 is 414. That's how the answer come. Okay, so this is the explanation. All right, so based on the explanation and the question given, and we can understand that basically our work is to check what is it, to find the summary of the of the value of that arc left quadrant. Yeah, if I'm not spelling wrong. Yeah, quadrant. Yeah. So and then we need to get the summary of, we need to get the sum of these 4 values, and these 4 values should be in the maximum case, right? So now I think we can just kind of discuss, we can kind of discuss what are the different cases. First, let's focus on the first elements, like in this 2D array, like what is going to be the possible values in the first element. Like we forget about 1 1 2. We just talk about the general case. We just talk about general case in like it could be any possible value of the element, right? So because according to the rule, like it's telling, where is that? Okay. Okay, so thanks for waiting me patiently. Uh, yeah, according to our rule, like we have read, is like especially in this case, like given the initial configuration of Q matrix, shall reverse the rows and columns of each matrix in the best possible way. Yeah, so it means that each columns and matrix is reversible. And then how to reverse? Here, maybe you can see that I don't know why sometimes it doesn't work properly. Explanation. Yeah, it should be there. Yeah. Mm. Where's the okay, yeah, all right, is here. So reverse column 2, so you can see this in this example. Like after reversion, like initially it comes from left to right, right? So and then at the end it is like we just write it in the opposite sequence. We write it from right to left, like 112 101 56 83, and then similarly for the and that is for the columns. Similarly for the rows, we also write down it from right to left instead of left to right. Okay, so in this case that means maybe we go back to our screenshot. So if we reverse it, like so so 119, if we reverse the row, 119 could be the possible value of the first like matrix of I and J, matrix of 1 and 1, right? So like this one can be 112 itself and 119 as well. And then 64, like in terms of we reverse the column, so 64 can be take place of this one, right? And then if we do 2 times reverse, we first reverse this row, and then here is going to be like 108, yeah, and 114 114, and then 98 and 62, right? So then and then we again reverse it, so that means 108. Yeah, let me erase that. So that means 108 can be also possible to come to the first position, right? So that means like we just only consider about the first item, it can have these four possibilities, and then we need to think about what are these positions. Like for example, in this case, it could be how to say, like matrix. Yeah, it could be the first, like the first column. Yeah, this 112 is first column. First one. Okay, maybe we can just write in a math way. 1 1, yeah, and then 1 4. 1 4 means the first row, fourth column, and then fourth uh fourth row and the first column. Okay, and then the last one is fourth row, fourth column, right? So this is basically the case, and yeah, and then we can think about again, like in order to make it differentiate, we can change your color, agua. Okay, so then here, in like similarly for the second item on the up left quadrant, it could be 42 itself, and also like after we reverse, maybe we just think about to reverse the same row, so it's going to be 119 here. Okay, 119, and then yeah, 119, and then 83, and 1112. Okay, no, sorry, not 112, is actually 42, and then at last only it is 112, right? Okay, so in this case, that means 43 can also be shifted, or say it can be shifted to this position. So yeah, so 43 can be the one, and then similarly we can take a revision of the column, right? So like we can reverse the column of this one, of this one particularly. Yeah, so and then after that it is going to be 98. It's going to be 98, and yeah, and 98 I'm not going to write, it's very time consuming. So yeah, 98 here, and 78 here, and 125 here, 42 to here, right? So yeah, maybe we can erase it. Yeah, so that means 98 can be also the possible value. Yeah, and then like I'm sure you can, is very obvious, like 114 can also be the case, because if we rotate 114 up, like it is going to be 114 here, and 101 here, 56 here, and 83 here, right? So 114 comes up, and then we again do the revision. So here, because 114 is here, so there instead of 183 114 is going to be take place. That's why we can also consider 114, and then similarly here, okay, here what is going to be is going to be like maybe second row, second column. No, sorry, first row, second column. Yeah, second column, and then it can be fourth row, the third column, right? 1 3, and then fourth row, second column, and the fourth row, the third column, right? Yeah, that's very simple. And now we are going to discuss about the third digit, means the position which 56 occupied here. maybe now what color would you like? Maybe we take yeah, maybe name. Okay, so in this case, like 56 itself can be there, and then similarly 49, yeah, can be there. I'm sure you understand why, because when you rotate here, then it's going to be, this one is going to be 49 here. Yeah, maybe let me erase 49 here, and then 56 here, and 56, 49 here, 56 here, and then 125 here. And again, the first 56 is coming to the last, right? So yeah, and then similarly, if we rotate the column, that means it also means the same. We do the same process. So like 15 can also be there, and then what's going to be last is going to be 43. Why? Because we can move 43 here and then reverse, and then it will go to this go to our target position. Okay, let me circle it, 43 here. And then at the last, like if you follow the same approach, yeah, I'm sure you are going to we are going to get let me put silver here. So if we follow the same approach, then I think the, yeah, is not, I think the truth is that the last 4 digits is going to be as the last to take place, like to be the 4 possible volumes of the last position on the up left quadrant. Okay, so now again, let's discuss about the position of, first let's talk about this name, the green one. So what is that? It is 2 1, right? 2 1, and then 49 is going to be second row, fourth column. And then similarly, this one is the third row, first column, and then third row, fourth column, right? And then the last, we check this zero one. 125 is basically the second row, second column, 2 2, and then 2 3, right? And then 3 2, and then 3 3 3 2 3 3 3 2 3, yeah, 3 3. Okay, and then we are going to convert it into array, so like, because in the matrix, like as you know, it starts from 0 and end with and end at like the n minus 1, right? So we assume if there are n number of the elements. So here that means everywhere here we need to minus 1. We need minus, so that means the first one is 0 0, yeah, and then maybe to make it simplified, I just write m instead to stand for matrix. Okay, so then this one 1 minus 1 is 0, right? And 0 3, okay, sorry, 0 square bracket 3, and then this one, the third one, is going to be okay, probably let me to, yeah, this one. Okay, and then the third one is going to be 3, yeah, 3 0. Okay, and then the last one is 3, because 4 minus 1 is 3, again 4 minus 1 is 3, yeah. And then similarly, the first one is 0, yeah, because the only thing we need to do is just minus 1, simply minus 1 is very simple, yeah, 0 1 here, and then m 0 2 here, and then 3 how much 1, right? Yeah, and then how much, how many 3 2, good. And similarly here is 2 minus 1, 2 minus 1 is equals to 1, yeah, and 0, yeah. And then you tell me what's the next one. So it is 2 minus 1 is 1, 4 minus 1 is 3, okay. And then 2 0, and then 2 sorry 2 3, okay, last 1 1, then 1 2, and then how much 2 1, right? And then 2 2. All right, so yeah, so now we need to find the regulation, the regular, and try to figure out what should be the formula between this one related to yeah, which is going to be related to the like the I or the row or column, right? So I think so. Then how should we do is that I think like first of all it is going to be a 2 with double for loop, that is obvious. And also what we are going to do with this is we are going to compare which among these 4 digits, okay, among each 4 possible value, what is going to be the last the largest, and we are going to do the summary of the largest, right? But what is the formula of this? So let's try to write a for loop for, yeah, I range. Okay, so in range, what is going to be inside here? We actually don't have to go through for the entire matrix. We only need the like a quarter of that, like, so that, and also we are using the double for loop, so that means it's going to be yeah, the total, the what is it, the total length of the matrix in the column, and then divide by 2, right? So yeah, here, because here we already get int, because this n is is basically the input value. Yeah, it always, sometimes it has problem about this. Okay, yeah, where is that? So the first line contains an integer q, the number of queries. The next q sets of lines are the following match, and then the first line of each query contains an integer n. So each of the next two n lines contains 2n space separated integer matrix I and j. Okay, so now what we are going to do is we need to put n divided by 2 here, right? But sometimes the value could be an odd number or even number, which makes float. So that is what we actually want. So and then therefore we can use, I show you, yeah, we can use this one. Instead of a single slash, we put double slash, because it will round the result down to the nearest whole numbers. So this can solve our problem. Yeah, very simple. Okay, let's put it. Yeah, that is for I, and then again we need to use another for loop for j, right? So similarly, because it is both for the column and the row, we take only half. So this is 2. Yeah. And now let's continue to observe about what's the regulation. Like because so like basically I starts from 0. It starts from 0 and end at the what is it? Yeah, let's see, because whenever we write some value it ends as the value -1, right? But because it is an array, so the like phi itself, it would be in the 6th position of the array. So that's why we have no worries about that. But let me have a think. So here, I think here for the first value, because I is going to be either 0 or 1, like we just consider the example given. Yeah, okay, it's very troublesome. So like we consider the example given, it is like it is 4 into 4 matrix. So here the n is equals to 4. We take this as an example, and then the value of I and j both would be either 0 or 1, right? So like I think in terms of I is equals to 0, like the first one is also 0. So then like this, yeah, and then in terms of I is equals to 1, later is going to be 1. So now I think we can confirm. Oh, sorry, yeah. Oh, sorry, I put the capital lock. Okay, now we can confirm matrix. Why matrix is because this volume was appended in the matrix. So it is a 2-dimensional array. Okay, yeah. So matrix, and then the first one, like we just think about the first volume, yeah, because there are 4 lines. The 4 lines, it would be the same. The what is it? The task which we are working is to find formula of these 4 rows, and then to use double for loop to make it in one single row, in one single line of the code, so that it can go through it automatically, right? So and then we have confirmed. Like the first, like this one, uh, yeah, the I, it will be the I. And then what about the second index? The second index sometimes is 0, sometimes it's 1. Yeah, if it's 0, um, probably we try for j here. We can just try for ij here, and now next we we think about the second one. Okay, the second one, I think for the first index I, it will be remaining the same as I, because here is 0011 again, right? And the previous was also 0011. Okay, so matrix I, and then the next one is slightly tricky. So it is 3232. 3232. So what is going to be this 3? So what's the relation? Like, oh, like for first, when I is equals to, okay, so in like probably we can copy it. Okay. Oh, sorry, I made it. Yeah, maybe this one we save somewhere. So what? Yeah, I always love screenshot tool. It's very easy to indicate things. Yeah, let's make it blue. So now our work is to figure out, yeah, what's the relationship between this with one. So I assume that in terms of we put I in front of in above j, so like we need to figure out what's the relation between this. Why here is yeah, why here is 3 when I is 1 is equals to 1 and j is equals to how much? J is, oh sorry, I is equals to 0, j is also equals to 0 in this case, and then the second one I is equals to 0, j is equals to 1, and then the third is I is equals to 1, j is equals to 0, I is equals to 0, j is equals to 1 for the last, and then we need to find about the regulation between this with this. So like because n is equals to 4, another one like for our total value n is equals to 4, so yeah, like if j increase and then like our targeting value decrease, right? So it's probably something minus j, 4 minus j, and then like now it's very obvious, we put 1 minus 1 here. Yeah, it's going to be done. So but we cannot write 4 as 4, we should write 4 as n, right? So this is n minus j minus 1. Alright, so next, don't worry, like we just write something, if there's somewhere wrong, later we come back and solve, right? So and then next, sorry, next is to figure out the third one. Like we now our target is to find the relation of this one with I and j. I was not supposed to remove. So this is 0, 1, 0. Okay, maybe I write it smaller. I is 0, j is 1, I is 0, j is, oh no, sorry, j is 0, j is 0, and then j is 1, and then I is 1, j is 0, I is 1, j is 1, right? So let's try to observe what's the relation. Oh, and also we need to remember n is equals to 4 again. Yeah, so let's observe the relation between this volume with 3, 3, 2, 2. So now maybe like is very obvious, this will be more corresponding to I, like as I change and this value changes. So like in this case, there won't be, we shouldn't write j there probably. So this is like we can think about n 4 minus, yeah, again because if it increase and then it get decrease, it gets decrease. So here it can be n minus I, and then we minus an extra one to make it in balance. Right, so now we can write matrix what was the previous one? Yeah, n minus I minus 1 here. And then let's think about the second index j. So the second one is yeah, I'm sure you realize that before I draw it. So 0 1 0 1. So what is this? What's going to be this? So it should be corresponding to this one, right? So like it is very obvious. We can write yeah. So it is exactly the same as j when the j changes. So why don't we just directly put j here? Okay. Next is the last one. The first index of the last one is as we can see here 3322 right here 3322. So like it will be more close to this. So what is going to be that? It's going to be yeah the same as this one, right? We put it minus, and then minus I minus 1, and then for the second index is corresponding to the value of I, right? So no, sorry, is corresponding to the value of j, and also n is equals to 4. So it could be yeah, again n minus j minus 1, n minus j minus 1, right? And yeah, and then next, because we are not going to 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 make the value separate, right? We are going to find like as I show you. So as we have discussed in our previous one, like we have already found the 4 possible volumes, and then we need to take the largest one to maximize it. So there is a very simple function. We just put max and then to put everything inside bracket. What happened? Let's try again. Max. Yeah. Okay. Probably we slightly break it to make it more visible. Okay. So the max is to find the maximum volume of an individual digit, like the individual of the first one, and then we have already used the for loop. It will check for the second one, third one, fourth one, right? So that means the max, like this value is just a single uh, individual item of the up left quadrant. So but our target is to find the summary of every volume of that maximized up left quadrant. So that means in this case we need to create a new variable. Let's just write it as sum. We initialize it as 0, and then here we can write sum equals to sum plus this one, right? Yeah, let's just put it here. And yeah, and then at the end, our work is to return return sum. Why? Because we then later write is basically to print it. So we don't have to print it inside. It will directly take the result. Like so that means we need to return a volume. Okay, so let's try it whether it is running or not. Oh, there is wrong answer. Don't worry. Your output. Don't worry, it's normal. Matrix. Let me have a think. Y J J I. Okay, yeah, I got it. We need to take n is equals to length of the matrix here. Yeah, because this n is something different. I made it wrong in like previously. Like it doesn't affect. So probably I put a capital N to differentiate. So n is the length of the matrix. Yeah, we use function and then we can get 4 value because it is like the 2D array, and so it will consider it as 4 because it's 4 into 4, right? Okay, let's try again. Oh, there's a mistake again. Okay, sorry, it was because I forgot to change this value as capital N because since I now I set it as capital, everything should be capital. Okay, let's do it. Alright, so let's try. Okay, it works, and let's try everything. Yeah, finally it works, and and then we can, to make it more simplified, we can just, instead of a sum plus, we can use this one to make it a little bit simplified, right? Yeah, again it works. All right, thanks so much for watching my video, and see you in my next video.